So before I get started, I just want to thank the organizers of Cascadia Fest. It used to be Cascadia JS. They work really hard on this event, and as someone who organizes events, they work really hard. So let's give them a round of applause. As a person who's from the Pacific Northwest, I am super happy I've been able to attend all 5 years. Hopefully keep that streak going. I also have some stickers, so if you want to get some stickers, come talk to me afterwards, and let's get this going. We need some audio. Oh, I didn't plug it in. That would be me. That's my fault. Oh, let's go back. Okay, start over.
Where in the stack is Carmen San Francisco?
Hello, and welcome to Cascadia. I'm Marcy Sutton, but you can call me the Chief. We're in the business of tracking down culprits of JavaScript confusion. We're ultimately after well-architected web development tools, orchestrating processes across the computer stack, and producing the most accessible websites ever. Every bug we'll ever chase down will be for the goal of making the web more inclusive for all. Now, Gumshoes, when you report for duty, I'll assign you a case. You'll go to the source and look for clues about where we are in the stack. That's where the chase begins. Any bystander is a potential witness who can point you in the right direction. When you finally catch up with a rogue process, you've got to put a stop to it. Be on the lookout. So, are you ready for your first case? Our first mission will take us to the home of hypertext and the World Wide Web, a place in the stack we love for its reach and archive potential. Ah, yes, the browser context, where we have built-in JavaScript objects like document and window, CSS styling, semantic HTML, and developer tools. Browsers have evolved quite a bit since the 90s. This is where your job starts. A front-end developer from Seattle said she witnessed serial focus drops, a severe issue for keyboard and screen reader users. Gumshoes, we better get this right. People with disabilities are depending on us. Let's take a look at a drop-down menu that's causing trouble in JAWS, a popular Windows screen reader. When the menu opens, focus is
Tab,
sent.
visibility.
Let's go back, sorry. When the menu opens, focus is sent into the first item.
Tab, visibility selector button menu collapsed. Enter expanded. Enter collapsed. Enter expanded.
Well, that didn't work. Focus was not sent to the first item, if you noticed. So to diagnose the problem, let's look at the markup. In this HTML fragment, the trigger button has 3 ARIA attributes on it that control a menu. ARIA expanded, ARIA has pop-up, and ARIA controls. Next to it is an unordered list with a role of menu. It's been bound to the trigger button with the ARIA controls attribute. There are list items in this unordered list with a role of presentation, and then the anchors inside of that have a role of menu item. There's no href attribute, if you can notice that. There are some tab index attributes. The first one has a tab index of 0, and the second a tab index of -1. Making things a bit more complicated, the dropdown is built with Foundation, a third-party UI library with its own dropdown component and open and close methods. Let's scroll down and look at the open function. See ARIA hidden changing to false here? That effectively unhides the menu from a screen reader, and it might be important. And then there's this JavaScript layered on top. We instantiate the Foundation dropdown with jQuery and bind it to both the trigger button and the menu. We've got a click handler on the trigger that toggles the menu, checking whether it has a class of open. This changes the menu from visible to hidden, also calling the Foundation open method. When it opens, we grab the first anchor and fire a focus event. Now, a link is usually focusable, but in this case, as we observed, it isn't. This is what we call a focus drop. What gives? Let's see if we can gain any insight by asking an expert witness. Cameron Cundiff is a developer at Thoughtbot and organizer of Ali NYC.
If I were you, I'd check to see if the element was focusable. And Don't forget to test it with screen readers.
Seems there are a number of potential culprits to the focus drop. We're sending focus to an anchor with a role of menu item, but it doesn't have an href attribute, which in this case is okay because of the role and the tab index of 0. It should be operable with the focus event since it has a tab index. When I tried opening it in JAWS, focus was dropped every time, reliably. But it sometimes happened with the keyboard too, so it's not JAWS's fault. What's going on here? Maybe it has something to do with Foundation setting ARIA hidden in a separate event handler. It must be a visibility race condition. Layering JavaScript event handlers on top of the Foundation dropdown, in this case, creates a race condition when ARIA hidden is set to false in a completely different script. This can be a problem for screen readers, which need elements to be accessible to focus on them. To solve this, try adding a set timeout call that delays the focus until the element is fully rendered, or you could watch for ARIA hidden to be set to false if you were worried about the arbitrary set timeout, the actual time delay. Then you can send the focus event to it, and it should be fully rendered and accessible. So since you solved the case, here it is fixed.
Tab, visibility selector button menu collapsed. Enter, expanded. Menu, visible to members. Visible to members. To move through items, press up or down arrow.
Now, if you felt confused working on that case, you're not alone. This is a frequent accessibility problem across the web, especially with client-side frameworks. But now that we've uncovered it, the word is out, and we can each do our part to improve focus management from now on. We can even automate it. More on that in a bit. Gumshoes. We need to expose information about objects in a user interface. We're looking for an important mapping for understanding hierarchy and context. Can you help find it? Let's ask Alice Boxhall, developer at Chrome, or at Google, working on Chrome and creator of the Chrome Accessibility Developer Tools.
I heard there's a platform alternative to DOM scraping that produces a tree of objects with role, state, and name.
That's pretty vague, but I think we have all the clues we need to solve this case. I can tell you we aren't necessarily in no JavaScript land because assistive technologies do use JavaScript. Otherwise, all these client-side frameworks would pose a huge problem. We're close to Way ARIA, the spec for standard accessibility attributes in HTML and SVG. ARIA provides a collection of accessibility states and properties which are used throughout various operating systems. An accessory to our suspect, but not our suspect. The HTML element API is the interface for elements, but it does a lot of things unrelated to accessibility. What about accessibility APIs? There are accessibility APIs in most modern operating systems that expose information to screen readers. They interface with the web browser to provide details through a tree known as the accessibility tree. As Alice mentioned, there are standard attributes for declaring an element's role, state, and accessible name, amongst other things. YARIA, or ARIA for short, is a way to specify accessibility information in your HTML and SVG documents. A role says, what is this thing, like a button. If you have a role of button, for some reason you can't use a button element, and you should really try to use a button element, this attribute will expose its purpose to an accessibility, to an assistive technology through the accessibility API. A state indicates what state it's in, such as ARIA expanded or ARIA disabled. And a property is anything that isn't a state or a role, such as whether it has a pop-up or whether it has an ARIA label. And you can go onto the W3C's documentation for the states and properties to look at the entire list. Here's one example of a browser feature enabled by accessibility APIs. A new accessibility node inspector in Chrome, created by Alice, our expert witness. I've published a resource on how to enable it at bit.ly/chrome-a11y. Nice job, Gumshoes. We've successfully uncovered a hidden slice of web development, accessibility APIs. This knowledge will help us in our transition from the browser context to a Node.js context. We'll need this information to cross-examine suspects in future cases, so hold on to your notes. Now, I got a hot tip about testing browser scripts with Node.js. The anonymous source was completely babbling on the phone, but I managed to get the gist pretty quickly. I need you to investigate how we can execute a browser script in Node, keeping in mind they are different contexts with different objects available. Are you up for it? Yeah. Check out this browser script from the AxeCore library. It's an accessibility API written in JavaScript. It references objects like window and document, which we need to test the DOM in a browser context. To write automated tools in Node will require AxeCore, which you can get from NPM. The Axe API says you can run an accessibility audit with the axe.alicheck method, which expects an element reference so it can run some checks. So here we're passing in the document object. Let's try to run this on the command line and see what happens. It didn't work. The window object wasn't defined. So that's a problem. What can we do about that? We need to test the browser, but we're in a Node context. What are our options? You could run it in the browser instead, where the document object and the window object just exist all the time as global objects. But that would take us out of automated testing and into manual testing, which isn't really what we want. Could we try passing around strings instead of real objects so they aren't executed until they're in the right context? That might work for something like Selenium WebDriver, where we can pass a script off to the browser and inject it before it's executed. But in this case, we're staying in Node land and not opening a browser instance. In order to reference browser objects, we need to shim them in libraries that call them from Node. So any behavior relying on things like window or document must be shimmed in so we can include browser scripts. Let's go back to our browser script, which was the source of the problem. As a script, it made a lot of assumptions about which objects were available. So when we called it from Node, it choked on the missing window reference. In our script wrapper, if we check whether it's defined and pass in an object, even if it isn't, that allows us to include the script in Node since the window object is no longer undefined. This solves our immediate problem, but we still need to locate a document object. And there's multiple ways that you could pass that in if you're using a testing framework. We'll catch that culprit in our next case. Gumshoes. A new hire monitoring our server is called to say they were ambushed and the README file was stolen. Now we have no documentation to train the interns. We need your help identifying the browser test engine and restoring the setup. We need a way to run tests like these that ensure keyboard support for a drop-down menu. By programmatically operating a drop-down in tests and making sure it works with the space and escape keys, we can declare accessibility intent for our drop-down. And that way, if other team members come in and break it, they will know that they broke accessibility features. Prevents regressions. There are multiple tools needed for accessibility test coverage, including a test runner like Karma, plus a framework like Jasmine or Mocha. But in this case, we need you to configure the browser engines. I've got a faint memory of automated tests whizzing by on the command line without opening in a separate application window. But that wasn't the entire picture. I remember browser tests that took longer to complete and they opened multiple menus or multiple applications and were more thorough. What can we use to test browser accessibility all the way to the end? Hey, a bystander from the Facebook accessibility team, Jessie Beach. Maybe she knows what we're looking for.
It made a lot of promises, and then it closed the window. What it really needed was a longer timeout.
That's awfully vague. Let's see if we can figure this out together. Was it usability testing? Probably not, because that's not automated, but that is really important. We talk about automated testing a lot, but you should really test your stuff with humans, and including people with disabilities. was it Phantom.js? It's a useful tool because of its speed and ease of integration, but it has some problems with focus. If there isn't a DOM that's attached, it might have some problems running those tests. It made a lot of promises and closed the window. That makes me think they used Selenium WebDriver. It needed a longer timeout. Yep, that's Selenium. Sometimes it needs a little more time to resolve, especially if you're hitting a remote URL versus a local one. So chances are a lot of your Selenium pain will be healed with longer timeouts. That's definitely the right part of the stack for accessibility testing. Here are a few tips when selecting a testing solution. You could set up tests with Phantom.js, which is a headless browser powered from the command line. It opens a page, traverses the DOM, and then performs actions. It's great for unit testing. It mainly uses JavaScript callbacks, and it's great for performance. But it doesn't handle keyboard focus consistently like a real browser would. Selenium WebDriver, on the other hand, opens a real browser instance, and you can open different browsers from Safari to Edge to Firefox and Chrome. It's great for integration or end-to-end testing. It's promise-based, so that's a bit of a change from Phantom, which is callback-based. But with a real browser DOM, it can help you avoid focus bugs like the ones in Phantom. I can smell the ocean from here. But we're not done yet. You've done a great job of tracing the evidence, but there's a major piece of the puzzle we still need to solve in our investigation. One of the most important tools for the job is on lockdown. Browser extensions, which make it easy to run accessibility audits at the push of a button, aren't working at all. Can you uncover the cause of a communication breakdown? Can you? Can you? I'm asking a question. For precedent, if we look at the Axe Chrome extension, we get this handy accessibility checker that can analyze a web page running locally or remote. If that sounds familiar, it's because it's the same audits we were trying to run from Node earlier. When we run the audit, the extension has to look at the DOM to report on its level of accessibility. But there's a problem. Extensions don't have script access to the content, and for good reason. There are security and performance concerns around extensions that have unlimited access. We need a way to run axe.alicheck on the DOM through an extension. But there's a missing piece to this communication puzzle. How does the sandbox extension context manipulate the DOM? Let's take a look at a demo extension I've created. It adds a button to the toolbar that runs an audit when it's clicked. If we want to test the DOM from this extension, we need to gain access to it. So we inject an API script once we have access, and then we can run the rules and return an audit result. But how do we get around the browser security model? We need to figure out, we need to go back to our demo. Let's go over here. Okay, so, nope. Aha, there it is. I can, wow, I see what Rachel was talking about with the mouse. Where is it? There it is. Suspense is killing you, isn't it? Oh, but we need our, let's get out of here. Okay, so over here, I've got this handy extension button that my extension added. And when I click it, it will run an audit on this web page. If I can click it. So on this page that has many accessibility issues, I was able to look at the DOM, inject Axe Core, and run the accessibility test, and then I just embedded them right into the page. But I had to get around that script context to be able to get access to the DOM. So let's figure out what that culprit is. So to figure out how that extension did its magic, there are a ton of APIs available in web browsers, from accessibility APIs to HTML elements to JavaScript. But in a browser extension, different parts of the UI are given different levels of access and different objects available. Despite the name and the blessed browser API access, event pages do not have object access to the DOM. So we won't run ax.alicheck there because it needs the document, it needs other DOM-related things to be able to report on the accessibility of it. So event pages are out. Content scripts, on the other hand, do have access to the DOM, and they have some access to API methods. In that content script, if we use Chrome's send message method, or in Firefox it's window.postMessage, we can actually use messaging to go back and forth between the different parts of an extension. So yeah, we're going to use messages to manipulate the DOM through the active tab, because you have to do a bit of checking to make sure that you're on the right tab, or else extensions gone wild would be manipulating things that's way too much control. So in this content script, we create a script element, and we load the ax.js script file, which we could get from NPM. We load that as its source, and then add a message handler, where we can listen for updates sent from various parts of the extension. So very event-driven model in extensions to get around the security issues. There's a manifest.json file that you can use to create an extension and declare the different parts, and I found that this process for Chrome was a lot easier than Firefox, but I heard that Firefox is working very hard to make it so that you can actually interchange your Chrome extension as a Firefox extension, so that's really awesome. So we saw how I was able to inject accessibility results directly into the page that we're trying to test, but in a real world, you would want to send them back to the extension. So the Axe Chrome extension, it needs access to the content through a content script, but it also has its own tabs and its own UI. So further complicating that, I found that there was a real gap in knowledge about how to even communicate between these different parts that are all sandboxed from each other. The Axe Chrome extension, when we run it on BuzzFeed, it has 213 accessibility issues, which is a lot. And there's Carmen. She eluded us the whole time. This is her fault. Oop, let's go back. So to recap everywhere that we've gone in the stack today, we chased down some really confusing cases. In screen readers, you might be trying to focus on an element that isn't there. This comes up a lot, and it's pretty common in screen readers to need to add a delay before you try to focus on an element. After having worked in accessibility for a long time, I will tell you that is a really handy thing to know. Accessibility APIs expose accessibility information through standard attributes like ARIA, but they allow assistive technologies like screen readers and screen magnifiers to have a tree of objects that they filter out things like metadata and stuff that's supposed to be hidden from a screen reader so that they can look at just the accessibility information. And the API system is what actually does the work to expose all of that. Browser scripts that you include in Node need those global objects to be shimmed so that you can actually include them. Because the first time I went to do that, I was wondering, where am I? What objects do I have? And how do I get around this? And so knowing what objects you have available and how you can shim them makes it so that you can build developer tools and have them work in different contexts. You can automatically test accessibility with Selenium WebDriver and Phantom.js and know that depending on the performance and whether you're doing a lot of focus testing, you might need to choose one or the other, but it's good to do both so that you can test each individual unit with Phantom perhaps, and then have Selenium do a whole dive through your whole app. Make sure that component A isn't messing up component B and that sort of thing. And then you can use content scripts and send message to get around the restrictions in extensions so that you can actually test the DOM. Gumshoes, your first day on the job was a success. Your logical approach to problem solving is very valuable, and we're lucky to have you here in Cascadia. I hope this builds your confidence in using web development tools to improve web accessibility for everyone. We need more high-caliber individuals like you committed to making a difference. Can I count on you to spread the word about the importance of testing for accessibility? I thought so. If you spent this entire talk wondering who Carmen Sanfrancisco is, because I did hear some people who grew up outside the US were not familiar with this. There was a legendary game show on TV, and there was a computer game that I played growing up. Where in the World is Carmen Sandiego stole my heart, because it was a really fun geography game. There is actually a playable version on the Wayback Machine, and there's a ton of videos of the old game if you want to walk down memory lane. So I'd highly recommend looking at that. And thanks for being part of my first ever JavaScript accessibility game show.